Good morning, students. Today we are going to consider internal energy. Internal energy is made up of by kinetic energy and potential energy of that individual particles of the system. Delta U is equal to U2 minus E1, means U1 is internal energies of initial state and U2 is internal energy of final state. This internal energy is state function and it is extensive property. It is state function because its magnitude depends upon initial and final state of the system. It is extensive property because the properties of the system depends upon quantity of matter. While discussing this internal energy, the energy transfer from system by cooling or by performing work on the surrounding is removed from the system. Means if work is done by the system on the surrounding, then energy whatever transferred from the system, it get cool or it performs some work on the surrounding, this energy is removed from the system. For example, if 30 kilojoule of heat is supplied to the system, it would be added to internal energy and internal energy change in internal energy becomes plus 30 kilojoule per mole. If 10 kilojoule of heat is released from the system, it does work 15 kilojoule on surrounding. On surrounding means it is expansion, and work of expansion is always negative. These quantities are removed from the internal energy of the system as delta U is equal to minus 10 plus into bracket minus 15 is equal to minus 25 kilojoule. That is 10 kilojoule of heat is removed from the system and 15 kilojoule of work is done by the system on the surrounding, and therefore change in internal energy is equal to minus 25 kilojoule. So you have to remember what happened. Internal energy is released or internal energy is absorbed. If internal energy is released, then it should be negative. So you have to remember during this the system gets cool. So cooling takes place in this case. Next point is first law of thermodynamics. So question can be asked that give any two statements of first law of thermodynamics. So you have to write statement as energy can neither be created nor be destroyed, but it can convert from one form into the another form. Then total energy of the isolated system is always constant. So you have to remember at least two statements. So first statement is energy of the universe remains constant. Second statement is the total internal energy of an isolated system is constant. And third statement is energy is neither created nor destroyed and can only be converted from one form to another form. The next point is formulation of first law of thermodynamics. In this formulation, suppose Q is quantity of heat. Q is quantity of heat supplied to the system and W is work done on the system by the surrounding, that is work of compression, and this work of compression is always positive. So W is positive, hence if Q Q quantity of heat is supplied to the system and work W is done on the system by the surrounding, the internal energy of the system would increases. Means if Q is supplied to the system, work is done on the system, then delta U is positive and it increases. This increase in internal energy of the system is equal to sum of quantity of heat supplied to the system and amount of work done on the system, that is delta U is equal to Q plus W, or for infinitesimally small change du is equal to dq plus dw. So you have to remember this formula of first law of thermodynamics. Okay? That is formulation of first law of thermodynamics. If we consider different process, that is isothermal process, adiabatic process, isochoric process and isobaric process, then how this first law of thermodynamics is applied for various process. In this first process is isothermal process. So according to formula of first law of thermodynamics, delta U is equal to Q plus W, as in isothermal process delta T is equal to 0, that is delta U is equal to 0, and hence this equation we can write as 0 is equal to Q plus W, that is Q is equal to minus W. So whatever heat is supplied to the system or heat absorbed by the system is directly used for work done on the surrounding, means work of expansion. So as internal energy is 0, this heat absorbed by the system is utilized to perform the work. So when work is done on the system by the surrounding, it results to release of heat. Means if work of compression is there, then heat is released. Next process is adiabatic process. In this adiabatic process, Q is equal to 0. Means in adiabatic process, there is no exchange of heat between system and surrounding, and therefore Q is equal to 0. Hence, according to first law of thermodynamics, delta U is equal to Q plus W, as Q is equal to 0. This equation becomes delta U is equal to W. This indicates that internal energy increases of the system during the work done on the system, means work of compression takes place. In isochoric process, delta V is equal to 0, or we can say that W is equal to 0. If W is equal to 0, then according to first law of thermodynamics, delta U is equal to Q plus 0, that is delta U is equal to Q, and in this case heat absorbed by the system is utilized to change the internal energy. Hence internal energy changes by using this heat absorbed. So it shows that change in internal energy of the system is due to the heat transfer at constant volume, as internal energy is state function, QV is a state function. QV means heat at constant volume. Then isobaric process. In isobaric process, P1 is equal to P2 is equal to P, means delta P is equal to 0, but P is not equal to 0. Hence this equation becomes delta U is equal to Q plus P external delta V. So you have to remember this equation. So this is about different process, and first law of thermodynamics is used for these different processes. The next point is enthalpy. This enthalpy of a system is sum of internal energy and pressure volume type of work. So enthalpy is equal to sum of internal energy and pressure volume type of work as U is a state function, pressure and volume is a state function, therefore enthalpy is state function. Question can be asked for 2 marks that derive the expression for change in enthalpy. So for this, if we consider a system changes from initial state to final state and change in enthalpy, it becomes delta H is equal to H2 minus H1, as H1 is U1 plus P1 V1 and H2 is U2 plus P2 V2. Therefore delta H becomes delta H is equal to U2 plus P2 V2 minus U1 plus P1 V1. Therefore delta H is equal to delta U minus delta U is equal to plus into bracket P2 V2 minus P1 V1, as P1 is equal to P2 is equal to P. Therefore delta H is equal to delta U plus P into bracket V2 minus V1. Therefore delta H is equal to delta U plus P delta V. That is delta H is equal to, we can write it is equal to QP. So you have to remember this equation. Question can be asked for 2 marks. Derive the expression for enthalpy change. Thus, change in enthalpy of a system is equal to heat transfer from it at a constant pressure. Enthalpy and QP are state function. This is very important. Enthalpy and QP are state function. So this is about change in enthalpy. Next point, question can be asked that derive the equation for relationship between change in enthalpy and change in internal energy for any chemical reaction. So as we know that at constant pressure, delta H is equal to delta U plus P delta V. Delta H is equal to delta U plus P delta V. For solids and liquids, this delta H is equal to delta U. This is because delta V is 0 for solid and liquid. This is very important point. For reactions involving gases, delta V is not equal to 0. So for gases, this delta V is not equal to 0 and we cannot neglect this delta V for the reaction. So consider any reaction involving in gaseous state. The equation is delta H is equal to delta U plus P delta V. Delta U is equal to delta H is equal to delta U plus P delta V, as P delta V is equal to P V2 minus P V1. For an ideal gas, this PV is equal to nRT. PV is equal to nRT. So according to ideal gas equation, this PV is equal to nRT. Therefore PV1 is equal to N1 RT and PV2 is equal to N2 RT.